What's tomorrow? Quest. 25 points. So those of you that did well on the first part, you guys do well again. Those of you that did badly on the first part, you got to do well to bring it up, yeah? Because the 25 points go together with the 75 points from the last test to make your Chapter 9 score. So, 9-6, 9-7, that's it. Let's go over as many questions as possible today. I think I extended your Google Classroom deadline until like 5 o'clock tonight or something, just in case, because the quiz isn't until tomorrow, but you were supposed to have it done today. But anyway, I extended it a little bit so you could ask me questions in class and for the people in the pre-ACT to have a little bit of grace too. But I was hoping they'd ask questions if they got stuck, but that didn't really work. 9-6 is over on this side. We don't have to worry about 9-1 to 9-5 at all. What did you guys want to, well, hold on, pause. This should not be the case, but just in case it is. I'm going to keep my head turned this way, although I could look in the TV screen and see you all, but I won't. If anybody needs to take a quick picture of the review, you didn't write it down yesterday, you didn't try it. Crazy, foolish, but oh well. Get the problems down now. And if someone needs to come up and grab a book, come on up and grab a book too so that we can access it. Do you guys notice, though, how there aren't very many problems in the review? What am I expecting you to go back and study? The homework. Yeah, the homework. And I didn't want to give you all the review ones because they're not necessarily all helpful. And if you guys notice, it's only 2 sections. There aren't tons of problems anyway. Let me point your attention really quickly to a few other places that you could study because some of you are really trying to do well on this one. There is the chapter test that I don't really assign until the end of the semester for review problems on your final review, the bonus points. But there are some review problems over here that might be nice, especially getting down into like the 15 and beyond, which isn't very much, sorry. But right down here in like numbers 13 to 19, those could be some good problems if you wanted to check out some extra problems. And then you could always go back to homework and you could try a few more, either the same ones that we did, not looking at the answers. Remember, you have to make your brain try it on its own without seeing solutions. Otherwise, you're just going to handicap yourself. And of course, we also have like some of the quick, short, sweet summaries over here, but I think the best thing for you guys to do is to be practicing on problems. So if you ran out of problems because you did them all last night, which is good, go play on 13 through 19 in the chapter test, and then go back to homework and retry some of those problems. Or go in the YouTube video, remember? Go to an example, pause it before I do it, and then check to see if when you try it, you understand. But here we are, section 9.6. Let's start there. Is there anything in section 9.6 you guys wanted me to go over? On the review first, 85 to 92. No? Anything in general? Okay, so you're good on 9.6 theoretically? Okay, so section 9.7, let's go there. Any questions that we have on 9.7? Oh, are we good? Are you sure? Okay. I gave really detailed descriptions as far as the quiz yesterday. Did you guys write it down okay? I mean, I could do it again, but it'd be the same hints. Okay, then I'm totally cool. Was there something else you wanted to ask me, Joe?
Yeah, 9.6.
Oh, on the homework, right?
Yeah, it's just like
okay.
Questions.
Yeah.
I got A and B. I just couldn't figure out why
C wasn't working out. Oh, these are the license plate. No, 3-digit number ones. Okay. And we know this is a section 9.6, like even if it wasn't in this homework, because of the wording of how many, right?
Yeah.
Okay, good. Uh-oh. My snipping tool is not happy. Okay, well, for the 3-digit numbers, we do want to go ahead and work through digit by digit as far as there he is. The fundamental counting principle, which is when I make those blanks, right? And when I make those blanks for letter C. Well, let me review real quick A and B just for others who are looking. If I'm thinking about them digit by digit, like ones, tens, hundreds, That'd be our A, that'd be our B, that'd be our C. Leading digit can't be 0. Remember, we're looking for single digits, which are 0 through 9, which gives us 10 different numbers. So 0 through 9 are all valid, 0 through 9 are all valid, 1 through 9 are valid, which is why A is 900. Letter B says, okay, leading digit can't be 0, only 9 options, and no repetition. Well, it was 10, but 1 just got used, so now it's 9. It was 10, but now 2 got used, so now it's 8. But in letter C, it says, once again, leading digit can't be 0. And to be a multiple of 5, this goes back to, it would have been in middle school somewhere, like how to get multiples of numbers. Just 5 and 0, yeah, 5 and 10. So there are only 2 options. Fair game. Oops, throwing out stuff. Which one? Yeah, at least 400. We could say something like, oh, it's all the digits 400 to 999. But my brain starts to get really confused as to how many is that, even though it should be easy. So I just like it like this too. And I say, at least 400, okay, 4, 5, 6, 7, 8, 9. I have 6 different options for leading numbers because I can't use 0 or 1 or 2 or 3. But otherwise, fair game. So as long as I eliminate 0, 1, 2, and 3. 4, 5, 6, 7, 8. Yeah. Did anybody else go over homework again and have questions? Yeah. Number 47, and then Chris, what do you got? Okay. Was 58 97? Sam, or is that 96? $67? Okay, so let's do Chris's first because he's in 96, and then we'll go Sam's in 97. So sorry, Chris, what number was it? 63. 63, oh, the defective ones. Okay, yeah. 63, shipment of 25 TVs contains 3 defective. And this is actually kind of similar to the whole, like, a deck of 108 cards, and these many are wild, these many are red, these many are blue. We have, like, a whole number as far as 25. But then we also have how many are faulty or defective. And how many ways can a vending company purchase 4 of these units and receive all good, bless you, 2 good, and at least 2 good? Okay. And this uses some of that wording that I talked about yesterday, right? So I first would say, okay, there are 25 total. There are 3 faulty, which means there's 22 good ones. Is that valid? 22 good ones, 3 faulty, 25 total. So when in letter A it says they're purchasing 4 units, I have to first ask myself, okay, somehow my brain can't contain all the different possible combinations. Oh. So I'm going to have to use some of my techniques. It's not like decks or cards in a deck or numbers on a die. So then, to that effect, I have to use either NCR or NPR. I said the word combination. Does anyone know why? Why would I say combination and not permutation? Yeah, the sequence, the arrangement doesn't matter. All I care about, is it good or is it not? This lump of TVs in front of me. So since it's a grouping, not an arrangement, I'm going to say NCR. So I'm going to say, okay, if all of them are good, that means that I'm only getting 4 out of the good ones. Like the faulty ones weren't involved at all. So how many different ways, how many different possible combinations out of the 22 good ones in the warehouse or in the shipment, how many ways can I get 4 of the good ones? So that's what would be letter A. It's just saying, hey, okay, cool. Out of the good, you have 22 good. You're getting 4 of them. Letter B goes one step further and says, okay, you're only getting 2 good. So out of the 22, how many different ways can I get 2 of them? But the problem is I have a shipment of 4. So if 22 are good, what must you have also gotten? 2 bad ones. So out of those 3 bad ones, you got 2 of them. And I'm connecting it with an and because it's one of those, okay, well, they told me I got 2 good, but I got 4 total, so I must have also gotten the 2 faulty. So I got the 2 good and the 2 faulty. And then letter C says at least 2 good, which one way of doing that is to add up the different ways this could possibly happen. So to say, okay, at least 2 good, you could have gotten 2 good, which is what we just got, or what we just wrote down. 2 good, and then that would have meant that we would have had to have gotten 2 bad. Or we could have gotten, 3 good. That was possible, because if there's 22 good ones, yeah, we could have gotten 3. But a shipment of 4, we would have had to have gotten 1 faulty. Or we could have gotten all good. So our different options are 2 good, 3 good, 2, 3, or 4. Either all or 3 or 2. But technically, once we learned section 9.7, you could have also done, I was thinking complement. You could have also done 1 minus, but we're not doing probability. No fractions, no decimals, no percentages. We're just counting up. So remember, section 9.6 are big numbers. No denominators, no sample spaces. But if this was a problem from section 9.7, they could have said something like, what is the probability of getting at least 2 good? If we take this problem to section 9.7, all of a sudden probability, we need the favorable outcomes out of the total outcomes. We could have taken our letter C and said, okay, that's possible, that's possible, that's possible. These are the number of ways it works. We could take that number from letter C, but what would our sample space be? Sample space says forget all the characteristics and just go back to the very beginning and say how many ways possible of getting a shipment. Sample space would have been like, I don't care what kind of TV. You have 25 and you're getting 4. Does that make sense? Hey. Oh, you brought it. Just here, it's just fine. Yeah, you can do it on my desk. Thanks, Kylie. So then coming over here, kiddos, we could have taken all the different possible favorable outcomes that you could have added up from letter C, and we would have divided by, like we did with the cards yesterday, what are the total and how many are you choosing? This is like, I don't care characteristics. Sample space just says total, I'm getting 4. All the particulars would go in the numerator. Is that cool? And then Sam, you wanted to look at section 9.7, right? What? 47? Oh yeah, before we go. 9.6? Yeah, my hero, thank you. Who is 68? There are tons of ands in this one. Does that make sense? Because you have to pick one of these. So you could do combination, because it doesn't really matter whether they do the hairline first or the eyes. They just get to choose them. You could do combination, but you could also just fill in the blanks, Lauren, with kind of like you just saw us do with the license, not the license plate. The 3-digit numbers. How many hairlines are possible? You're only choosing 1, so 195 is in the first blank. How many eyes are possible? You're only choosing 1 set of eyes, so 99. So you could have filled your blank with 195 times 99 times 89 times 105 times 74. Well, you could do 195 C1, 99 C1, all be C1, and when you just are choosing 1, it's the same thing as the number. So kind of like with the, I just erased it. Because you have to choose a hairline and eyes, and noses, and mouths, and chins, like the telephone number you did yesterday. Remember how we had to do 1 digit and another digit and another digit with how many options? Same thing here. Yeah. And is times, what's or? Plus. Just look for overlap, maybe you have to subtract. But then in letter B, Lauren, they say the eyewitness can clearly recall the hairline and the eyes and the eyebrows. That's like yesterday when the first 3 numbers were established, 1, 1, 1. So your hairline would just be, they know that, 1. They know that one. They know that one. How many other things do they have to choose? Noses, mouths, and chins only. So those 3 blanks would have the 1, but you would still have the unknowns as far as the having to multiply. Or just 89 times 105 times. Because combination permutation, we really only use NCR and MPR if we're needing to choose more than one. Yeah. Like telephone numbers, you're just choosing one. Or like license plates, you're just choosing one to fill a blank. But like what Chris brought up, the televisions, you were getting 2, you were getting 4, you were getting 3. That's when we have to bring in the NCR. Yeah, 68. Okay, if you guys want to follow with us, you don't have to. You can be working on corrections. You can be playing with the review. You can be writing 7 times any things that you think you need to memorize. But we're going to peek at 47. Thanks, kid. Sometimes there are too many numbers in math and I can't keep them all straight. Oh, nice. Sam, do you see how this is really similar to what we were just doing then? In the sense of instead of TVs, now we're doing microwaves. And instead of doing just counting up how many, we're totally doing probability. So then, Chris, you'll get to see your idea applied in another problem. And we're using some of the words like exactly, all, at least, like I hinted at yesterday. Joe?
It's just like and means like have to fulfill both of the condition and probability, or means you have a good.
Well, remember, and can mean multiple things.
Yeah.
So one way is that it needs to be red and a jack, so 2 conditions true at the same time, 1 card. Or it could be like what Chris brought up, or even this problem here, where you're getting so many good and so many bad. It's just a connector word. So you have to think of and 2 different ways. Does that make sense? Okay. So we have 12 total. And those 12 are split up into 3 faulty or 3 defective, which means I must have 9 good. Does that make sense? So I have 3 bad and 9 good. A vending company has ordered, oh, well, okay, it's kind of lame. I know, I'm sorry. They're using 4 again. Whisper, 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 whisper. Because each has identical packaging, the selection will be random. What is the probability? So I need some sort of fraction, not big numbers, but some sort of fraction with favorable over sample space, that all are good. There are 12 microwaves. You're getting 4. That's the sample space. Like, I don't care, good, bad, I don't care. There are 12. How many different shipments of 4 are possible? How many different ways could they have chosen 4 to send off to me? That's what the sample space is. But the numerator says, oh, well, if all 4 are good, then how many groupings of 4 are possible from the 9? So out of all these different ones, how many of them would have only entailed good? Does that kind of make sense? So the 9 good, you're getting all 4 good out of, well, I don't know, out of all the different possible combos. But then in letter B, when it says exactly 2 are good, so not at least exactly, well, if 2 are good, that's not my whole shipment because I'm getting 4. So if 2 are good, you have to read into it and realize, oh, 2 must have been bad. So then I have to say, okay, I got the 2 good ones and I got 2 bad ones. So there's that and saying, okay, I didn't just get 2 microwaves, I got 4, so I must have gotten 2 from here and 2 from there. How many different of these combinations would involve this situation? Sorry. Yeah. Yeah. So I have my, how many different ways could I have gotten those 2? Not many. That would have been like the first and the second and the third, or the first and the third. So there's not many ways of getting it, but there are a few different ways you could have gotten that. Mm-hmm. Yeah. Because I had to get 4 total. They told me 2 were good. So 2 out of the 9, how many ways could that happen? But I must have also gotten 2 out of the 3. that cool? And then letter C goes one step harder, and it says at least 2 are good. With probability, I actually have 2 ways of doing this. One way is what you just saw me do with Chris's, which it was the only possible way with counting up how many ways. Because counting up, you have to say, all right, how could you get at least 2 good? Well, you could take 2 good, this situation. If you got 2 good, you must have gotten 2 bad. But at least 2 could also be met if I had gotten 3 good. That's true. So 3 good, okay, well, this would have changed. I would have gotten out of the good 3 of them. Sam, how many bad ones would you have gotten? Out of the 3. But your shipment's only 4, so you only would have gotten 1. But there's also another or. You could have gotten all good ones. There are plenty of good ones. It's possible that you could have gotten all 4 are good. So you could have gotten all 4 good. And you could do times 3C0, but it's not going to change anything. It's just a 1. And then that would have been over your sample space. Yeah. Because bottom is just how many ways could this happen in general. I don't care about favorable, unfavorable. How many ways can it happen? The top says how many ways can this be done. Sometimes. I don't know. For shipping microwaves? Well, this is talking about how if a certain warehouse has a percentage. You understand, Joe. They're not like, ooh, it's bad.
It's so terrible. It's like 4 out of 12.
Oh, that'd be a horrible percentage. I totally agree. But they're trying to keep the numbers low, I think. So then the or, Sam, the other way, which maybe your brain likes and it will do, but maybe it doesn't like. Sometimes it's really hard to add up all the ors. I think we had one the other day where it was like at least 1 and there was a shipment of 200 and it was like, oh, this is going to take forever. So there is a way of saying, okay, all the possible ways of this happening is 100% minus. All of this is leaving out something. There is some time when this could, if this is anything 100% out, there is something else happening. And the other possibility of getting at least 2 good ones, well, if you only get 1 good one, this is false. And if you get no good ones, this is false. So then false, I can do complement, which says, okay, what's the probability of getting the other condition or the other side? And if I subtract from 100%, I'll get all the ways that it does work. What if I gotten only 1 good one? So 9 good ones. And then I would have gotten all 3 bad ones. And then usually I'd say, okay, well, what about 1 good one that fails, but 0 good ones that fails too, except can I get more microwaves than... I can't have gotten all 4 bad because there aren't 4 bad to begin with. Yeah. So I only have 1 way this actually fails because of my only 3 bad ones. I can't possibly get no good. I have to at least get 1 good in my shipment of 4. So then if I put this in my calculator, which is it okay finding NCR? Yeah. If I put this in, 1 minus this will be the exact same as adding up all the ways it does work. Yeah. A decimal that you could make a percentage. Like a 0.15, which would be 15%. It'll be higher than that, but yeah, definitely. Definitely. Anything else you guys have come up against as far as in the review in section 9.6 homework or 9.7 homework? Is there anything that we have questions on how to use our calculators for NCRs, for fractions, for NPRs? Don't forget to study those factorial formulas. It could be. It'd be a super nice, easy one, because then if they gave you the probability of it happening, you just have to subtract from 100 to get the not. And that's all that it is. Yeah. Anything else you guys see? Yeah.
On the repeated formula, you said that the top could be NPR 2.
It won't be tomorrow, because that one starts to get very convoluted and a bit, like Joe mentioned, a bit confusing as far as whether or not it's accurate. So yeah, tomorrow the repeated ones will only be you're rearranging all the letters. So you get to do n factorial over the repeat factorials. Yeah. Anything else you guys see? All right, I totally don't mind if you guys work on corrections.